Hi, and welcome to this second video for the Tupton Hall School Practice Paper 2. This is question 2, and it's designed for Core 1, made for AQA, but it's suitable for other examples too. As ever, if you want any more information, you can contact me on Twitter at Mr_G_Walton, or follow our school account at Tupton Maths. So this is the second question, and it's in two parts. The first part's asking us about this function here, f of x. It says that it's equal to 4x cubed plus 21x squared minus 24x plus 1. And it asks us to find the set of values for which the function f of x is increasing. Okay, now there's something that we need to think about when with this word increasing. When the function is increasing, what do we know about it? Well, we know that the gradient at that point is also increasing. So if the function is increasing, then this question is going to be about the gradient function. It doesn't say it is, it doesn't tell us anywhere that we're looking at differentiating it, but it's exactly what we're going to do. So we're going to say that f dash of x is greater than 0 when f of x is increasing. So let's work out what the derivative of f of x is, f dash of x. So f dash of x is going to give us 12x squared plus 42x minus 24. Now we want this to be greater than 0. So 12x squared plus 42x minus 24 is greater than 0. And this is the inequality that we're now going to solve for x to find the set of values of x for which the function is increasing. I can see straight away that all these terms are even. 12, 42, 24. I'm going to see if I can take a common factor out first, just to make my life a little bit easier. I was going to say that 12 goes into them all, but it doesn't. 12 doesn't go into this one. So let's go for 6. 6 goes into all of these values. So let's take a common factor of 6 out. And then I've got 2x squared plus 7x minus 4 is greater than 0. Let's see if I can now factorise this. So I'm going to see if I can stick it into two brackets. Remember, it's still greater than 0. Let's think. So we're going to have a 2x, and we're going to have an x. The only two values that I can think of that multiply together to give me 4 are 2 and 2, or 4 and 1. Now, if I have a 4 here, when I multiply this out, 4 lots of 2 are going to give me 8, and 1 lot of x would give me 1. I can make a 7 out of an 8 and a 1, I know I can. Okay, here we go then. So let's put a 4 here and a 1 there. Let's just think about the signs. I want to have positive 7x, so this arrangement would work, because if I were to multiply my brackets here, I'd get 8x minus an x. So that gives me positive 7x. This works lovely. Okay. Let's think about what the solutions would be at this point then. In order to make this equal to 0, x would have to be, in this bracket, a half, and for this bracket, minus 4. So let's sketch the graph. This will help us with the inequality. Just a quick sketch to see what's going on. It'll intersect at a half and minus 4. Something like this. So here's a half, here's minus 4. Because it's an inequality, I'm interested in when it's greater than 0. So I want all the values that gives me greater than 0, and that's above the x-axis. So here and here. So the two different solutions I can have are when x is greater than a half for all this portion here, and when x is less than minus 4 for this section here. So find the set of values. Let's actually answer the question. The set of values for x are when x is less than minus 4 and when x is greater than a half. Okay, and that's our final solution for part A. Part B says the graph of y equals f of x crosses the y-axis at the point P with the coordinates 0, 1. Calculate the equation of the tangent to the curve at point P, giving your answer in the form ax plus by plus c equals 0. Okay, well, an equation of a line we can write in the form y minus y1 equals mx minus x1. And we can do it like this when we've been given a coordinate, and we have been given a coordinate that it crosses through 0 and 1. So I actually know x1 is 0, y1 is 1. What I don't know is the gradient, but I've already differentiated it. I've already worked out what my gradient function was. So we had f dash of x was, let's see if I can remember, it was 12x squared plus 42x minus 24. Now, we've been told some information. We know that this is the gradient function. We're looking at the gradient at a particular point when x is, let's have a look, when x is 0. So let's work out what it would be if I substitute 0 in. Well, 0 squared is 0, multiplied by 12 is 0, so I've got nothing plus 42 times nothing, nothing, minus 24. So the gradient from this, we can say that m is minus 24. So therefore m is minus 24. Let's substitute all the values in and let's get this equation then. So I've got y minus, now the y coordinate of my point is 1, so y minus 1 equals minus 24 lots of x minus 0. Let's tidy this up. So I've got y minus 1 equals minus 24x. It wants it in the form ax plus by plus c equals 0. So I want everything on one side. So why don't I add 24x to both sides, and now I get 24x plus y minus 1 equals 0. Okay, nice 3 marks for that one, mainly because we've done a lot of the hard work already by differentiating in the first section. Now, notice that these questions again aren't leading you through nicely on how to do this. It's a simple question in terms when you know what to do, but we've had to use a multiple of different things again. We've had to realise its differentiation, we've had to then use quadratic inequalities and equations of lines for this part here. If you're taking notes on this sort of information, this is a good time to do your revision card notes. Differentiation questions might not have a dy by dx in the question. They might not even talk about stationary points or maxes and mins. The key word on this one was increasing. We were then using a gradient function with our good old friend y minus y1 to find the equation of the line. Don't worry about these sorts of things at this stage if you're not picking them up straight away. That's the whole point in you doing these papers, is so that you can build up your confidence, start spotting these more irregular questions, to enable you to have confidence that when you stand up and line up in the hall ready to do your exam, you're sitting down, you're opening the paper for the first time, that you can actually access these questions, and really there shouldn't be any surprises. I'm hoping that by asking you these more difficult questions and giving you the video solutions, then you're going to feel more confident. Okay, so don't let it knock your confidence. Good luck. If you need anything, get in touch.